Alright, hello everyone, once again. Welcome to SNY Maths, helping you build a foundation for your mathematics. Either you are in grade 10, you are in grade 11, or you are about to finish metric to have a quality results. Remember, the session is free. It's on the YouTube channel. You can watch it direct, or you can download it and rewatch it over and over again. This section is going to be focusing on trigonometry, grade 11 content. A grade 10 learner, you can still watch it because some of the information are grade 10 information, but the build-up continuation is a grade 11 continuation. Grade 11 is very important. You focus immensely on trigonometry, which is paper 2. It is the second topic that has got a lot of marks if you take your Euclidean geometry out of that paper. Trigonometry has a lot of marks there. Without further, I would also emphasize the fact that you would need to have the mindset in grade 11 that your grade 11 report is what is going to be used. The final year report is what will be used for your tertiary application, meaning in 2022, when you are in grade 12 and you are applying to university, you would need that grade 11 report. Hence, your maths is a very crucial part that you need to get a quality results, because now education has been competitive. Universities are taking learners with top quality achievement. So if you just pass general pass, you may not be able to obtain a proper course of your choice. So quality results matters a lot in this case. That's why we're trying to help you wherever you are, reaching out to you. Since COVID is destructive to our learning and teaching, we're finding all means to support you wherever you are. Okay, so I'm going to go straight into trigonometry, as I said, and the session that you're going to have today is going to be based on your grade 11 trig. There's be 3 sections that we're going to deal with. The first is the introductory part, getting ourselves more familiarized with our trigonometric ratios, your Cartesian plane, how to use reduction formulas. So you come across all these terminologies: trigonometric ratios, your reduction formulas, your co-ratios, the signs of the trigonometric ratios on the Cartesian plane, how to mimic all those. So I'll go straight into it, starting from your trig ratios. So I'll start with your trigonometric. Trigonometric ratios. I'll be using the Cartesian plane a lot in this section to explain all this information that you need to have in mind. The ratios that we are going to be dealing with, I would want to explain it on your Cartesian plane, as well as on a right-angled triangle, which has got a 90 degrees. So if I draw a circle around this Cartesian plane of your y and x, and draw a line from this point to this point, which, if this is the origin, this is the center, this line is going to be your radius. Drop a line here, and then sitting on the horizontal line will give us a 90 degrees, because you have a vertical and a horizontal. This is going to be your x-axis, and this is your y. Let's say an angle theta is formed in this angle here. So that is how this will display. If you take it out as a right angle triangle, then you have something that looks like this. So instead of us using R, X, and Y, I'll use H for hypotenuse, which is the longer side. I'll use small letter A for adjacent, where the two angles are formed, and I'm going to use O for opposite, the side that is facing the angle or facing the hypotenuse. So with this, let us come up or write out our three ratios using the angle theta, sine theta, cos theta, and tan theta. All right, the easy way to get this is by using these acronyms, starting from sine, which is SOH, CAH, and TOA. So your SOH stands for sine, S is for sine. So these two letters is your opposite and your hypotenuse. And from the diagram, we can see the opposite side is your Y, the hypotenuse side is your R. So I'll have Y over R if I'm using this diagram. If I use this diagram, I can then write sine as hypotenuse, which is my opposite, which is O, over hypotenuse, which is H. Likewise for cos, cos is adjacent over hypotenuse. So my adjacent side on this diagram is my X, and my hypotenuse maintains as R. With this right angle triangle, my adjacent is going to be A, my hypotenuse is going to be H. And lastly, if I look at my tan theta, which is opposite over adjacent, the opposite side is to your Y, your adjacent is X. Therefore, I would have Y over what? Over X. If I use this right angle triangle, then I'll have my opposite to be O, my adjacent is going to be what? It's going to be A. These are your what? Your trigonometric ratios, and this is how they are being what? Expressed. Okay. Now, from this, I'll look at the signs of the ratios. The signs of the ratios on the same what? Cartesian plane. And I would want you to pay attention to that so that you don't get lost when you are now using this the ratios and their signs. Remember, this is your y-axis, this is your x-axis. When we have a point, let's assume we have a coordinate here, A. Let's say there's a point here for y value. Let's say 3, and then the x value, which is what? Let's say 2. You can see that both numbers are positive. Wherever you move this point, let's say you move it here, still the numbers may change, but the signs will not change. If you move it here, the numbers may change, but the signs plus plus will not change. Hence, what I want you to understand is that with the trigonometric ratios for your x and y values, for all the three ratios, your sine of an angle, your cos of an angle, and your tan of an angle in this quadrant, which we call this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All the ratios are going to be plus in this quadrant. So sine theta is a plus, cos theta is a plus, and tan theta is a what? Is a plus. 3 of them are all plus plus. All right. But if you go to the second quadrant, your ratios, your sine theta, your cos theta, and your tan theta will behave like this. Your sine maintains as what? As plus in the second quadrant, but your cos and your tan are going to have a negative signs. So here all of them are positive. Here only sine is positive. In the third quadrant, your tan theta, your cos theta, and your sine theta. This is the behavior in the third quadrant. Your tan will be positive, but then your cos and your sine are going to be negative. So in the third quadrant, tan, let's put it as big letter T, tan is what is positive. And lastly, if you go to the fourth quadrant, your cos theta, your sine theta, and your what? And your tan theta. With these, your cos will be positive, but your sine and your tan are going to be negative. You will need this when we come to the reduction formulas, how to reduce the reduction formulas to a single ratios. These signs are going to be what? Are going to be important. So in shortcut, here you see C is what is positive. If you put these letters or the initials together, we can have something called cast. Cast. You can easily remember the word cast, or if you don't remember, you live here in Cape Town, you can say all station to Cape Town. If you are not in this province, you're in a different province, you can say all students take what? Take commerce. It may never be true, some does science, but for commerce students, it makes it easier for you to remember that if you're doing commerce, then it goes for you. But that is an easy way to remember, meaning the all means the first quadrant, station means the second, take means the third, and then commerce means what? The fourth. So it's in that order: first, second, third, and fourth. So with the all of them are positive. With here, S is positive, the rest are negative. 10 is positive, the rest are negative, and commerce for course is what is positive. Okay, so with this, I'll take you now into your reduction formulas that you would need to know in grade 11, because that is going to be highly needed in simplifying your trigonometric expressions. So again, I'm going to use the Cartesian plane to come up with the reduction formula. If I'm sitting at 0 on the x-axis and on the y-axis, an angle on the x-axis that is not moved anywhere will be 0 degrees. When I move 0 to this in the first quadrant, I would have a 90 degrees. From 90 to this angle, I would have 180. This is the second quadrant. I move to this, I would have my 270 degrees, which is my third quadrant. And back to this, I would have 360 degrees, which is my fourth quadrant. In each quadrant, there are two formulas that we are coming to discover now, and these two formulas are going to be used in solving trigonometric expressions, trigonometric equations, and any other question that you may come across that will be necessary. So in the first quadrant, remember, any angle that is formed here will be an acute angle. And what is an acute angle? It's an angle that is less than 90 degrees. So I'll say 90, that means below 90. 90 minus minus a theta. That is my first reduction, my first formula that I need to know in the first quadrant. At the same time, if I revolve around the circle to 360 and I move again over 360, then I'm gonna have 360 plus. So I can also form an angle in the first quadrant that is 360 plus what? Plus a theta. 360 plus a theta. I want to remove the what? The circle that I drew around this, and rewrite this again. 360 plus what? Plus a theta. So in my first quadrant, I have two of the formulas that I've listed here. Go to your second quadrant. When I move above 90 now, I'll have 90 plus a theta, and below 180, I'll have 180 minus what? A theta. That is the other two in the second quadrant. If we come to the third quadrant, above 180, I'll have 180 plus a theta, and when I move below 270, I'll have 270 minus a theta. That is the other two for the third quadrant. And lastly, the last two that you would need to know is in the fourth quadrant. Above 270, you would have your 270 plus a theta, and below 360, you would have your 360 minus a theta, which is very important. So as I'm using what? I'm using theta as my angle for all the quadrants. Let's add theta when I'm moving clockwise. Theta is positive here in the first quadrant, and when I'm moving anti-clockwise, let me add theta here. Theta will be what? Will be negative in this quadrant. You would express all this information in terms of the trig ratios, your sine, your cos, and your tan, except these two, which would differ from the rest. These two here, your 90 plus theta and your 90 minus theta. So bear with me, we're gonna combine two things. We're gonna combine your reduction formulas and the signs of the what? Of the trigonometric ratios to write down how does this reduction formula simplify using the what? The trigonometric ratios. So I'll start off with your sine with all the what? All the formulas that are here, except your 360 plus, your 270 plus, and then your 270 what? Minus. Both of them are useful, but then preferably, because they are in the same quadrant, you can use one at what? At a time where necessary. So let's start off with sine. Let me use a black ink. Let's start off with your sine of all the what? The reductions. So your 180 minus your sine 180 plus, and then your sine 360 minus. Yes, obviously you can express these others, 270 minus 270 plus also. Focus on this main. If you can use the 180 plus, then you can use 270 minus. If you can use 360 minus, then you can use 270 what? 270 plus. So these three, how did they change in terms of what? Simplifying the reduction into a single ratio. Remember, 180 minus is in the what? Is in the second quadrant, and the sign of sin in the second quadrant is plus. So the first is going to be sine theta. The sign remain as what? Positive. Nothing will change. But if you go to the third quadrant where we have 180 plus theta, your sin will still go to sin theta And remember, sin in that quadrant is what? Is negative. So this is going to be negative sin what? Sin theta. Going further with 360 minus theta, again, sine is negative in the fourth quadrant with its sign. So 360 minus theta would also be your sine theta, but rather what? Minus. So that is sine with the three what? Reduction formulas simplified. Let's take a cos. Your cos 180 minus theta, your cos 180 plus theta, and then your cos 360 minus theta. The same way we dealt with the sine, the same way we're going to deal with what? So first go to the quadrant. Your reduction, cos in the second quadrant. Your cos in the second quadrant is minus. Your cos in the third quadrant is minus. But your cos in the fourth quadrant, where we have 360 minus theta, is a plus. So these guys will change to minus cos theta, and then plus what? Plus cos theta. Minus, and a plus. Here, let me use a red sign so that you see it properly. So all this information is necessary for you to memorize, to understand and memorize them, and be able to use it when you have a question. Because trigonometry, most of the information is to recall, remember it, and apply it. If you can't recall it, then the question will be sitting, you cannot do anything. You will leave the question untouched. Yes, now check your 10 with the three reduction formulas that I've listed here. Your 10, 180 minus theta, your 10, 180 plus theta, and then your 10, 360 minus theta. So first identify the signs in each of the reduction. What is the sign of 10? 180 minus theta is in the what? Is in the second quadrant. If you look at the sign of a 10 in the what? In the second quadrant, we discover that it's minus. In the third quadrant is a plus, it's minus, it's a plus, and it's minus. So in going to our simplification, we will find out that 180 minus theta in the second quadrant is going to be minus 10 theta because it's in the second quadrant. And 360 minus theta is going to be minus 10 theta because it's in the fourth quadrant. But your 180 plus theta will be plus what? Plus 10 theta. 180 plus theta is in the third quadrant, and 10, which is your t, is positive in that what? In that quadrant. So this is your reductions, formulas, and its simplification. Remember, I circled these two and I said I would deal with them separately. Your 90 plus and then your what? Your 90 minus, which is referred to as your what? As your co-ratios. Co-ratios, they switch between sine and cos. 10 is not included. These, in terms of reducing them, you switch between sine and cos. So I'm going to list them here and let's see how do they simplify. So I'll start with your sine 90 plus theta, and then your sine 90 minus theta. and then your cos 90 plus theta, and then your cos 90 minus theta. So these are co-ratios, meaning, as I said, this formula switch to what? From sine to what? To a cos. From sine to a cos, from cos to a sine, and from cos to a sine. As cos of an angle, cos of an angle, sine of an angle, sine of an angle. But one thing we need to pay attention to is the signs. Is it plus? Is it minus? Is it minus? Is it plus? We need to now look at that part. How does this information affect the what? The simplification. So looking at your 90 plus, remember when you go to the diagram, 90 plus is formed on the what? On the second quadrant. What is the sign of sin in the second quadrant? In the second quadrant, sin is what? Positive. So simplifying 90 plus theta in the second quadrant of sine will make this guy remain as what? As positive cos theta. The sign is positive. Sine 90 plus theta, sine in the what? In the first quadrant is also positive as well. So cos theta will still maintain as what? Positive. Then when you go to cos 90 plus theta, sorry about the plus sign I put there, cos 90 plus theta. Remember 90 plus theta, cos in the second quadrant is what? Is negative. The co-ratio is sin, but then the outcome is going to be minus sin theta. And then your cos 90 minus theta is obviously in the first quadrant. So the co-ratio is sin, but then the sign is what? Is still positive. This is your co-ratios. So here we have your co-ratios simplification. All this information is for you to understand, but then this is not the real deal. We're going to use this in solving questions in the next session. But the last one that I'm going to look out now, remember, I place these guys here in the first and then the second, the first and then the fourth quadrant. I placed theta negative, theta positive. Going clockwise, if an angle is formed here, that is positive theta. And if an angle is formed here going downward, this is negative what? Theta. So we want to express negative what? Angles. That is the last part you would need in solving your trigonometric what? Simplification. So negative angles. Negative angles with the what? With the trigonometric ratios. So your sine of a negative theta, your cos of a negative theta, and then your tan of a negative theta. How does these what? These guys simplify. Remember, we're still using the what? The signs in the what? In the fourth quadrant. Go to the fourth quadrant. Let's remember ourselves in the fourth quadrant in terms of the sign of the ratios. Look at these guys here. Your cos is positive, your sine is negative, your tan is negative. So we're using this to simplify where we have a negative angle. What does this change to? So it's going to be based on the signs that we have in the what? In the quadrant. So in the Cartesian plane, cos is positive in this quadrant, sine negative, tan negative. So because I have my angle formed in the what? In the fourth quadrant as negative. It is only cos that is positive in that quadrant. So if I have cos of a negative angle, it will change to cos theta with a positive sign. The remaining two are going to be negative. So this is going to maintain as negative sine theta, and this is going to be negative tan theta. All right. This is your negative angles. And lastly, I'll end it with your identities. Two identities that you need to know in grade what? In grade 11. Grade 11 quantity. Two identities, your quotient, and then your square identities. These two very important. So with your quotient identity, it simply says tan of an angle is always equal to sine theta over cos theta. And then with your square identity, it says sine square theta plus cos square theta is always equal to 1. How did we get this guy here? You're not required to prove this guy, but let's quickly show you how we came across this guy. Remember when we did the we did the ratios from here. We express sine and then and cos from this guy here. Sine is y over r, and then your cos is x over r, as well as tan. So you're going to use that information to prove that is it true that tan theta is equal to sine theta over cos theta. What is your tan theta? Your tan theta is equal to your opposite side over over adjacent side. Your opposite side is y, your adjacent side is x. So if we can prove that sine theta over cos theta is equal to y over x, then this is equal to tan, because tan is equal to that. That is the formation. So let's see, what did we get on sine theta? We say sine theta is opposite over hypotenuse. Opposite over, let me write it properly here. We said that sine theta over over cos theta. We prove that sine theta is your opposite over your hypotenuse, and then your cos theta is your adjacent over hypotenuse. Let's use the letters x, y, and r, because you're going to get something like this. So your opposite is your y letter, your hypotenuse is your r, so I've expressed this in terms of that. Your adjacent is your x, and your hypotenuse is your r again. That is your sine over over cos. In doing this, simplifying this mathematically, y over r, this is division. So for us to change this division, we change it to multiplication, which is your algebra. When you change this division to multiplication, remember the fraction at the bottom is going to reciprocate. It's going to reciprocal. Reciprocal means the arrow come up, the x will go down, meaning r becomes a numerator, x becomes a denominator. So we're going to have r over over x. And from here we can see that I've got r on top and r at the bottom. I can cancel, meaning I have y over over x, which I said your tan theta is equal to your opposite over your what? Your adjacent, which is your y over x. Therefore, we can say that tan theta is equal to sine theta over what? Over cos theta. We call this the what? The quotient identity. We call this the quotient identity. You would use this in proving identities of trigonometry. When it comes to that point, I'll remind you, I'll refer to that. Finally, let's look at the square identity. Where did this guy come from? The square identity came from your Pythagoras theorem. The Pythagoras theorem says that x squared plus y squared is equal to what? R squared. So you want to use the Pythagoras theorem to prove that a sine square theta plus a cos square theta is equal to what? Is equal to 1. So just let's see how we come across. How do we get this? So in get this to prove that it's true, I'll divide all the 3 terms by r squared. All the 3 terms by r squared. If I do so, on my right hand side, I'll be left with 1, which is this guy here. On this here, I would have y over r. Both of them are sharing a square, so I can put a square on top. And then on this side, I have my square. Both are sharing, so I can say x over what? Over that. Now tell me, from your trig ratios, we have sine theta, we have cos theta. Let's see. What is sine theta? We say sine theta is opposite over what? Opposite over your hypotenuse. Your cos theta is your what? Is your adjacent over hypotenuse. So from here, we can see the sine, which is y over r. So I can say sine square of an angle. Replacing this, the square comes onto the ratio x over r cos squared of an angle, all equals to what? 1. It's still the same because of the cos is here, cos is on the other side. But when you add in, addition is commutative. So cos squared plus sine squared is always equal to what? 1. This is referred to as the what? The square identities. Alright. So grade 11. This brings us to the section 1 of trigonometry. All this information that we have discovered are going to be useful when now we are getting into the what? Into the application part of the what? Of this information. We will deal with simplification of trigonometric ratios. Then we go further into what? Into proving of identities, which will be our third section. And lastly, we will look at what? We will look at your general solutions. So thanks for being here. If you've watched up to this point, we still have a lot to share with you. This is your foundation that you are building. Remember, solving for x and y is to build your what? Build your knowledge for your own benefit, and also to help you improve your mathematics. We're not charging you for anything. You're having access to this tutorial for free. Help us build the channel by getting more people on the platform. Also subscribe to the channel for more information. You can tick the notification button, so whenever there's any video that is uploaded, you'll be able to have access to the video. As well, you can download, share with your peers, encourage them to join and have access to these videos and watch. Further information that you may need to clarities from us, you can always reach us on, if you check the site www.symeds.net. Our email and our cell number is there. There is a Facebook channel that is also linked there. Our Instagram account is also there, so we can interact there via all these platforms. Thanks for watching once again. We hope to see you. Continue watching and build your mathematics as the year progresses. Thank you.